Hello again. So in this video, I'm going to talk about dictionaries. I'm going to talk about the basic dictionaries and how they can be implemented in the methods that the dictionary has, as well as the association list, which inherits the dictionary's trait. So dictionary is a parent class which has all the necessary methods for the dictionary, and association list is a child class which implements the necessary methods that the dictionary defines. So dictionary map keys to values. So there's always a key value pair exists, and we can search and remove by its key. Dictionary is also one of ADTs, as we've seen before, like stack, queue, and stuff. So different implementations are possible. There are many data structures that we can use to represent dictionaries. Sorted array of like key value pairs, a list of key value pairs, hash table, and etc. So it's an ADT, so there are like many other implementations are possible. So in dictionary, there are three big methods. We call them as get, put, and del. So for get, we put key value as its parameter, and we return the value associated to that key. In case of put, we are basically adding a new key value pair into the dictionary, and if there's a key already existing, we just overwrite the value for now. And for delete, we ignore the keys that are not present, but if the parameter has a valid key value that can be removable, we just remove the key value pair together. So here's an association list. As you can see, there's a diagram that is based on linked list. So we implement this association list with linked list, and this acts like a dictionary. So I will go through the drawing and show how a linked list become an association list dictionary. Okay, so I will talk about linked list for a bit. So we've been seeing linked lists so far. So let's say it's like data, and this is like a data next, and let's say 7, 9, like that. This is pointing to the next element. This is head. So this is what we've seen so far. This is the linked list that we've seen so far. So in this linked list, what we can do is there's like a get nth element, right? Basically, we can't perform like get key because its const looks like self data and self next, so we cannot do anything other than like get nth because we don't really store key values at the same time. So for get nth, how we do this and what is the complexity? So for get nth is, let's say, def get nth, and we get the parameter, let's say n, because we would like to search up the nth value. So what we can do is we need to keep the index. So let's say let I equals 0, and let's say let cur equals to self.head, right? We start from the head, and while cur is not equal to none, we check whether it reaches the nth element or not. If I equals to n, we do return this current node, or we can also return like current data. This is what we can do. Depends on your implementation. If this is not the case, we just increment cur.next, and we also need to increment this I value. So the runtime here is definitely O of n, because we basically need to iterate until we find this nth element. So this is pretty inefficient, but this is the best that we can do right now, because this doesn't have a key to look it up. This is not a hash table. So this is just a basic linear lookup. So this is how it's done and the complexity of it. So the next thing that we will going to talk about is dictionary and the association list. So the list was like data, and next this was just a list const. And in case of dictionary, we have 3 values: key, val, and next. So this is for the dictionary. So you can see that their fields are different, right? So we have to also add this key value to the struct so that we can perform the dictionary operations. So it can be like struct cons let's say key, let val, let next. So the difference is that we just add this new value to the node so that we can keep track of this key value. So this is the basically conversion from a list to the dictionary. We need to redefine the node, the cons, so that we could perform like a dictionary operations. So the get method is quite different from the list get. So in list we can only get nth element, but in case of dictionary we can get element the value based on the key. So this is the special method that we could define. Let's define the method together. So def get key. What do we do is we also need to iterate. This is pretty inefficient. So let's say let cur equals self head, and we also iterate again, not equal to none. We check whether it reaches the key value or not. If cur key equals to the key that we are trying to look it up, we return the current node value or whatever. And otherwise, if we didn't find the key yet, we just update the cur node to the cur.next. This is still inefficient. The runtime is essentially same as the list because we need to iterate anyway. So this is also of an linear runtime. So you can just remember it as the basic linear search is a of n linear runtime. So that's the thing that you have to keep in mind, and you need to also keep in mind that converting from a list to the association list, that needs a new variable in its cons. Say that it's like key, and we also need to make sure it becomes a key value pair. And in case of association list, we can now look it up the value with a key. So we can define a new method like this, looking it up the key and search it up. So that's how we derive to an association list from the linked list. So as we seen in the diagram, looking it up, the get key method takes linear time, and it reported a poor complexity result. But complexity is not everything. maybe your dictionaries are really small, so it's not really affecting. Let's say your N is 10, it's not really a significant factor in that case. And it might be the simpler, like, than the alternatives, like compared to other ADTs that you could use. So that's pretty much it for dictionaries and association list. In next video, we will be talking about the hash table.